have reached out to some of you to shortly present your local context and experience in order to learn from each other and start group discussions later. So I wish you all for a very fruitful deliberations and discussions.
Thanks, Benjamin. So I'm just going to share my screen. Okay, so thank you, Benjamin. So welcome everyone. This is the third in a series of webinars that we're working together on to introduce the concept of forest genetic resources and tree species diversity into forest landscape restoration. And as Benjamin highlighted, the topic of this session is local always best in seed collection for restoration, particularly in support of decision making on seed sourcing. We're going to have this as part of a two-part series. So this first session is really looking at the sort of background details and then moving into the decision support tools that are available related to this topic in the following session, which will be in some weeks or a month's time. So it's very much a two-part process. Before we go into the details of it, I'd like to do a few sort of housekeeping meeting sort of coordination points just to try and make this run as smoothly as possible. So I'd like everyone to please keep your microphone muted when you're not talking, as this will help with the recording and also with the background. And it's best to keep your video on if you have the bandwidth, because it enables us to all to interact more. But if you have bandwidth problems, you can turn your video off. We'd like to ask you to keep all questions and comments, which are very valuable. So to really keep this meeting as open as possible, every question and comment you have is valuable to the discussion. But please use the following approaches: either raise your hand using the Zoom function if you're familiar with it, or turn your video on and use your hand to make the point that you'd like to make an intervention using the video. And if you prefer, you can also introduce a point using the chat function in Zoom. We'd ask you to please keep your comments and questions to the point and on topic, so not to go on to a long discussion, but to actually very poignant questions, so we can keep the meeting as efficient and concise as possible. And just to reiterate that all of the materials that we'll be using throughout this webinar and the recording of the webinar itself will be made available online afterwards. So I'd like to just introduce you to the panel of experts. We had a very quick round. I think we don't have time to do detailed introductions of everybody during this beginning of this meeting, but I'd like to highlight the key people who are involved in this webinar and the expert panel who will be involved in the session. So myself, I'm Chris Kettle. I'm the theme leader in Forest Genetic Resources and Resilient Landscapes at the Alliance of Biodiversity International and SEAT. And with me in this webinar are Hannes Geisberger. Hannes is a spatial analyst specialist who's been very involved in a lot of our work on species distribution mapping and developing decision support tools. David Boucher, who is a research scientist from the University of Oxford in the UK and an honorary research fellow with us at the Alliance. Tobias Fremel, he's a PhD student who's been heavily involved in our work on decision support tool development. Gabby Wiedeker, who is a research fellow with us, and actually is Gabby's birthday today, so we should all give a big wave out to Gabby to wish her a happy birthday today. Marius Ekwe, who leads our work on forest genetic resources from Africa, and Rina Jalalin, who leads our work from Southeast Asia. And so this is the team of people who are both working in the coordination of this webinar, but also will be the sort of expert panel for addressing questions. So the format of the session today is quite concise. We're starting with the introduction and the objectives of the webinar, which we've already had. We're going to very soon go into the presentation by Hannes Geisberger, and then we'll have a Q&A based on Hannes's presentation, which is a video recording, which I will stream from here. And then following that, we've got two additional presentations from John Ngugi from the Kenyan Forest Research Institute and Ray Tibiting from the Philippines Forest Management Bureau. And the purpose of these very short interventions is to kind of get us in a point of discussion and interaction, that we'll go into some breakout groups, which I will coordinate. So it will be completely controlled. You don't need to do anything for the breakout sessions. You'll be deployed to breakout sessions, and then we will bring you back at the end of that time to a plenary for reporting back and discussion. Each breakout group will have one of the panel with them in the breakout groups, and the panel expert who is in each breakout session will take some notes and report back on the discussions that were had, and then we'll have a summary at the end of this exercise. So I'll just pause there and ask if there are any brief questions of clarification before we move into the webinar. No, great. Okay. So while I'm just getting the video ready, maybe Hannes, you want to very briefly introduce yourself and the presentation.
Well, yes, as Chris already said, I'm working as spatial analyst or GIS specialist in the Forest Genetic Resources Conservation and Restoration team, and started a couple of years to develop an online support or decision support tool looking more deep into species vulnerability mapping. And we've recorded a presentation to give you a detailed input, and I see that right now also Tobias Fremont has arrived, because this is a sort of teamwork that we did there. So starting in different geographies and bringing the methodology really now on a very stable and so it's very tested and stable now, and we're in a very exciting phase of really upscaling that, implementing it in many different species and in different geographies, as the methodology is now really stable enough. And I'm happy to discuss and answer your questions together with Tobias and the team after the presentation.
Great, thanks, Hannes. So without any further ado, we'll start.
A quite important part of our work. It's on mapping tree species vulnerability to multiple threats as a guide to restoration and conservation. And the exciting, I would like to mention that we're in a quite exciting phase right now, because the methodology is now stable and really comprehensive enough to be implemented on a large scale. And this is something that we are also coming to towards the end of the presentation, when it's about scaling up. But now I would like to start and show you, on the basis of two case studies from two different regions. One will be presented by myself, and the other one then from Tobias, explain what it's all about. I hope you can hear me well. Okay, and now the slide is not.
If your slide's not moving, then just click in the middle of the PowerPoint and then it should start moving.
Okay, now it works. Thank you very much. So why vulnerability mapping in general? Understanding and describing the impact of different anthropogenic threats on tree species population is essential really for the planning of conservation and restoration activities. And we are showing here two photos showing very important threats to tree species population. One, land use change, deforestation, and the other one on forest fires. Okay. And we developed this own methodology for the main reason because many vulnerability assessments are not really spatially explicit. Here is one example of the IUCN Red List of threatened species, where you see an example of an endangered category. So there is no spatially aspect there. So to be honest, in the assessment phase, there is a certain, let's say, spatial aspect, but at the end, what you're getting out of the IUCN Red List is something that is definitely not spatially explicit. Then there are many vulnerability assessments out there, but only very few, or many of them have focused on climate change as the main threat, some also on land use change, but there are only very few studies out there that they also look into very important other threats. And last, also that in many articles it's assumed that different species are equally sensitive to threats. This is also something that we were trying to overcome. And our research questions were mainly, how could we design a spatially explicit vulnerability mapping method to estimate the impact of different current and also future threats to different tree species in different ecosystems? So from the beginning, the idea was very clear that we wanted to implement that really globally, as we work in 3 different regions, where we also have forest genetic resources networks. And secondly, how could we be able to translate these patterns of vulnerability into concrete recommendations for conservation and restoration activities? As Arvin briefly mentioned, me and Tobias, we are working with Chris Kettle in the Forest Genetic Resources Conservation and Restoration team. And as far as we know at the moment, most likely this will be mainly allocated in the biodiversity for food and agriculture labor of the new alliance, but this is not completely clear now. But in any case, we see lots of interaction or lots of important linkages also with other important levers there. And for example, climate action for sure, as we do a lot of climate change modeling, and you will see this in a couple of minutes, but also digital inclusion, and for sure as well multifunctional landscapes, but there might be others. This is for the moment what we see as very clear and important linkages. So coming now to our case studies, one was financed by the Austrian Development Agency in the parklands of Burkina Faso on threats to different food tree species, and the other one financed by the German Federal Ministry on dry forests in Peru and southern Ecuador, laying the foundations for climate smart restoration, a toolbox for Peru's tropical dry forests, a very highly threatened ecosystem. Now the methodology itself in a nutshell. So we're working on one hand with key threats, and I will show you in a couple of minutes which are the most common ones or the ones that we were able to assess in a spatially explicit way, from which we will develop the exposure maps. Then our target species, for which we develop distribution maps and we assess the threat sensitivity, and all together will then be used to create our vulnerability maps at the species level and also more. But let's start with the species distribution maps. So we are modeling the distribution of our target species for the simple reason because in many cases it's not exactly known where the natural distribution or the actual distribution of the species is. And a broadly used technology or used modeling is called habitat suitability modeling, but also species distribution modeling, SDM, and ecological niche modeling. So this is more or less really pointing to the same principle. The best practices are, on one hand, there is a software or an algorithm called MaxEnt, maximum entropy modeling. It's at the moment the most widely used single algorithm, available as standalone Java application and also inside different R packages. And on the other hand, the more recent ensemble modeling approach, which is combining different algorithms for suitability modeling, also available in different R packages. And we wanted to mention here the biodiversity R package, developed by a colleague of us from the CGIAR from ICRAF. What these models basically do is it's starting all from species occurrence points that you see here in the geographic space. You see basically the coordinates, the latitude and longitude coordinates of our tree occurrence, so single tree species. This geographic space is translated into an environmental space. This means that we extract from the occurrence points environmental data. As example, you see here precipitation and temperature. but actually it's a multi-dimensional space of around 20 or 30 different variables where the extrapolation is occurring. And then the results are then translated back into the geographic space, where you see, and this is maybe easier to show you directly, a typical output of the distribution modeling, a map that looks more or less like this, modeled potential distribution. In this case, it's one of the parkland species, the important socio-economically important species in West Africa, but also Central Africa. And you see here this, my mouse is again, these black dots are the occurrence points, and the colored area is the model distribution or the habitat suitability here from yellow, relatively low, to blue, high suitability. And it can also be interpreted as probability of presence. So at this stage, we're assessing or trying our best to assess the distribution of the species. In reality, we always, or in many cases, also use expert feedback to refine these maps. But I'm not going into this detail because there is not enough time in the presentation here. And the next step is then to look into the threat exposure maps. So now I'm showing what type of threats we're looking more into deep. So we are basically dividing them into current and future threats. This is now the example from the study in Burkina Faso, but actually we found out that later on these key threats are more or less the same in every ecosystem. There might be slight changes, but in principle, it's more or less the same as here, like overexploitation, different forms of overexploitation, overgrazing, fire, cotton production, or maybe in a broader sense, conversion to agriculture. And in the case of Burkina Faso, mining and climate change. And for the current threats, we start looking for the most appropriate, and appropriate in sense of the most high resolution and most recent data set, able to describe the spatial patterns of the threat exposure throughout all the study area. So in my case, it was the national boundaries of Burkina Faso. In the case of Tobias, it was the dry forests in Peru and southern Ecuador. And indicators for such, in order to express those threats in a spatially explicit ways, for overexploitation, maybe I'm getting a little bit more into deep. A very important factor here, of course, is the population density, human land use and infrastructure. So like roads data set, important assets for accessibility. You see here also the spatial layers that had been used in the Burkina Faso study and the impact at the population level. The other threats are looking more into, let's say, overgrazing is looking into livestock density. Here also the data set, fire frequency, land use change. But I'm not going now into all the detailed steps. Important here to mention that the climate change as future threat is basically, as you have seen in the, or as you have heard now in the previous slides, that we are modeling the current, we are modeling the habitat suitability of the species under current climatic conditions. We remember precipitation, rainfall. And we are also able to project this suitable habitat into future climatic conditions. And this is now, I'm going to show it to you now in the next slides, how this actually look like. For the current threats, or the threats that we are measuring in the short term, because we have already data sets to do that. These are the examples, as you see, for Burkina Faso. On the top left, overexploitation, you see here a map of accessibility. These dark black areas can maybe easily distinguish this as the road networks for Burkina Faso, whereas the other darker areas are densely populated places. Here in the center, more or less, there is the capital of Burkina Faso, Ouagadougou, the highest population density in the country, and down to very low density or area that is not so easy to access, or it takes longer. Similarly, You find here the maps for overgrazing, the density of livestock, for fire, the density of single fire events that we downloaded in this case from a very nice and very powerful online tool from NASA on single fire fire occurrences over a couple of years. Then agricultural expansion, you see here the cotton production intensity, and in the case of Burkina Faso, also the mining activities. Mining activity was an important threat. You see here. Yeah, and at this point, I'm going to hand over from Burkina Faso to Tobias and his dry forests, but methodological, it's going still ahead with this red line of the threat exposure map, and Tobias is going to guide you through the second part of the presentation.
Yes, thanks a lot, Hannes. So building further on the methodology that was developed by Hannes and colleagues, we also made this kind of exposure maps for the dry forests of the north of Peru and the south of Ecuador. As said, very similar, with one minor change that we made here, as Hannes already mentioned. So we considered habitat conversion in general, rather than the cotton and mining that was considered in Burkina. Then the next step is to estimate the sensitivity of each of the studied tree species towards the considered threats. In Burkina Faso, Hannes and colleagues developed an expert appraisal approach to do so. So they asked to local experts, or experts of local flora, to assess the sensitivity of each of the species towards each of the studied threats, with the table like you can see on this slide. And this has the advantage that it's relatively easy to implement, and also it has the advantage that it can capture all the aspects that may be included in the concept of sensitivity. On the other hand, it has the disadvantage, or Hannes and colleagues found that different experts often gave quite different sensitivity estimates. And this may be partly related simply due to the fact that the concept of sensitivity for different experts may mean slightly different things. And another necessary condition to implement this approach is simply to have enough of experts with excellent knowledge about the species. And this is not so easy in the dry forests of North Peru and the south of Ecuador, because they have a lot of endemic species, and also because they are really very understudied. So instead, in Peru, we tried, in Peru and in the south of Ecuador, we tried a different approach in which we estimated the sensitivity of tree species using species traits. So on this slide, you can see an illustration of this idea. So for example, for species with unpalatable leaves, so leaves that cannot be eaten or that goats and cattle don't like to eat, they're of course less sensitive to overgrazing. And then, for example, another example, species that grow fast, we assume them to be slightly less sensitive to climate change because they also have shorter generation times. And then because of these shorter generation times, this could permit them to adapt a bit more quickly to climate change. So the last slide showed some examples, and this slide shows now the full threat sensitivity assessment approach we applied. So for each of the threats, we linked them with a number of species traits. And in addition, we gave a different weight to these traits. So for example, for fire, we gave the highest weight to the trait bark thickness, because based on literature, we found that several studies have found bark thickness to be the most decisive trait in determining species sensitivity to fire. Then the next step is to combine all these things, is to combine these distribution maps, these exposure maps, and these sensitivity estimates into threat vulnerability maps, of which you can see an illustration on this slide. So basically, we start from the exposure maps, we mask those by the distribution maps of each of the species, and then we multiply those maps by the trait-based sensitivity estimates, or in the case of Burkina, the expert-based sensitivity estimates. And combining all these things, we obtain the maps you can see at the bottom of this slide. So for each of the species, for each of the threats, we obtain a vulnerability map, again with values ranging between 0 and very high. Yeah, so and on this slide you can see also such an example of vulnerability maps, again for Parkia globosa of Burkina Faso on the left, and then on the right you see so these species-specific vulnerability maps aggregated to one single map, in which the values of the grid cells show the number of species that are under high or very high vulnerability to at least one of the considered threats. Then these vulnerability maps can be analyzed in many different ways, but very shortly, a few main results of these two studies. So in Burkina Faso, Hannes et al. Found on average 60% of the species distribution ranges were under high to very high vulnerability towards at least one of the threats, while in Peru and Ecuador this was only 46%, which is still a high percentage, of course. And then another important finding in Burkina Faso was that climate change and overexploitation were the most important threats to tree species, while in the dry forests of Peru and Ecuador, we found that habitat conversion, overexploitation, and overgrazing were more important threats than climate change and fire. In Peru and Ecuador, we also did a sensitivity analysis, and this analysis pointed out that our results were relatively insensitive to the trait weights we used to estimate species sensitivity, but that they were quite sensitive to the thresholds that we used to make these exposure maps. So for example, for livestock, for vulnerability to overgrazing, we made these exposure maps by setting a maximum overgrazing exposure between 50 and 100 tropical livestock units per square kilometer. But of course, if you set this threshold was then based on literature, but if you set this threshold, for example, to 80 or to 120 instead of 100, this was found to quite influence the results. Then, using these priority action maps, using these vulnerability maps, we then made priority action maps showing areas recommended for conservation and restoration. And we did that like this. So here you can see an example of such a map for Lucina species of the dry forests of Peru and Ecuador. So we then recommend for each of the species to do in situ conservation of seed sources in areas with low vulnerability to climate change and also low vulnerability to current threats. This to ensure the genetic quality of the seed sources. Then we recommend ex situ conservation in areas that have high climate change vulnerability. And we recommend active planting or assisted regeneration in areas that are under high vulnerability to current threats, but low vulnerability to climate change. So we assumed that this high vulnerability to current threats means that the area is probably more degraded and therefore more in need of restoration, whereas the low climate change vulnerability is mainly meant to simply ensure that the tree species that you're protecting or planting on the site can still persist under climate change. Then we made these maps for all the species, and we also made them freely available in an online visualization tool, of which you can see the link here on this slide. And then similarly, we also aggregated these priority action maps for over all the species, making a map showing for each grid cell how many species are recommended for conservation there, which you can see here on the left, and how many species the grid cell is recommended for restoration, which you can see here on the right. Then, as Hannes already shortly mentioned, we are currently in the process of outscaling this methodology. So ongoing is applying a very similar methodology in Southeast Asia, in the App4GIS project, and also in Central Africa in the Copernicus project. That's with the first one is with Rina and colleagues, and the second one is with Marius and colleagues. And then, as you can see here also, there are still a few other planned projects in which we also are planning to apply this approach. And then ultimately, we hope to integrate all of these maps in an online platform, which is currently being developed and which will be called treediversity.org. So if all of this has gone a bit quickly, maybe, here are a few things that we hope you will remember of this presentation. First of all, we developed a methodology to make vulnerability and priority action maps with recommended areas for restoration and conservation at the species population level. We made these maps, We made these maps available in a user-friendly online tool, which should be easily accessible and interpretable by practitioners and policymakers. And finally, we think that our methodology can easily be adapted to other species, other countries, other ecosystems. Thank you.
Okay, so I think the purpose of that introduction there was to give you some idea of the work that's involved in understanding the threats to different tree species and the implications of that in terms of relationships to climate change and other land use threats to seed sourcing as an opener to this discussion. And I think we've got now time for questions to Tobias and Marius before we move on to the discussion. So if you'd like to ask questions, so Benjamin, yeah, go ahead.
Thank you for the brilliant presentation, for both of you. I just want to ask you, because you mentioned you did a sensitivity analysis in Peru. Did you also do that in Burkina Faso? Because there it was based on the expert knowledge. Have you done that?
No, in Burkina Faso, we didn't do a sensitivity analysis on all so assessing the entire methodology. This was something that came out later on. We applied a consensus approach to the expert validation or the expert estimates, what is a way of basically giving weight to expert knowledge based on the consensus of the others. And this is also in a detailed, so this is described in the methodology in a very detailed way, but not the sensitivity analysis on what were the most influencing factors. So this was done later on, and this is now, let's say, the standard way of how we implement it.
Okay.
Did it answer your question?
So David's got his hand up. I think.
Sorry, I was just wondering, and I may have missed something, in the Peru and Ecuador example, how well did your recommendations for in situ conservation coincide with existing national parks or protected areas, or didn't they at all?
Well, in fact, we considered these protected areas already when making these maps. So for example, for vulnerability to overexploitation, we already considered effective an area is protected or not. So in that way, yes, they very much, or to a great extent, coincided with these protected areas. But that was because we already included them in the process of estimating this vulnerability.
Mm. But sorry to continue, did you find any of the protected areas, could you identify them as being more susceptible or less susceptible to any of the threats?
Well, yes. For example, I mean, in general, for example, protected areas which are really located in a matrix of highly populated areas, they still got some. I mean, as a result of the analysis, still got some a certain level of vulnerability, and well, in fact, even not all the protected areas in that way ended up as recommended for seed sourcing. Mm. Because some, and that's also true in the field. Some are just so close to many human populations that people still put their cattle inside the area, still go there for firewood and so on.
Thanks.
Okay, Matilda, you have your hand raised.
Yeah, thank you very much for this really good presentation. I was particularly interested by the threat, how you managed to evaluate the threats, actually, because it's always an issue. I guess you are all familiar with the ROAM methodology, the assessment of restoration opportunities, where we mainly work on degraded areas, and then we see what are the opportunities. Do you know if this way of calculating threats have been used in restoration opportunity mapping? Because if not, I think it's really interesting. I feel we'll only work on what is already degraded and how we'll degrade it, how we can restore it, but without this notion of threats that you are introducing, which I think is particularly interesting.
Well, maybe Hans can continue later, but yeah, I'll answer first. For me personally, I'm not aware of threats being implemented or being included so explicitly in restoration planning in other initiatives like ROAM. On the other hand, it's also good to mention that only these threats are only are also just one part of the story, of course. So it's important to check in the field if these areas that we think that are highly threatened and therefore probably degraded are also degraded in reality. But yeah, I agree that there's quite some there's certainly an opportunity to include some more of these threats in the ROAM methodology too.
Thank you.
Yeah, not a lot, but because I'm also not aware that this is included into this, so other restoration approaches. What I saw is that this a more simpler way is of accessing threats, and specifically in protected areas. I have seen that in the European Union that they were assessing the protection status basically of protected areas using similar proxy layers like accessibility or population density, but definitely not in a species sensitive way. And I think the methodology then, or let's say more specifically the recommendations for conservation, then I think it gives you a lot of different opportunities basically, because on one hand you have your higher threatened areas and your probably degraded land, and you can basically decide on where you want to focus your intervention, or depending really on this is very project specific, but you would also find, using this methodology, you're also finding the least threatened area and the areas that are most likely having high diversity and low threats that could be. So it depends on your goals or on how you want to implement your in situ conservation areas, but it definitely allows you to find highly and also very lowly threatened areas. And this, I mean, we didn't go that far now in the presentation, but this spatial approach can then of course be also combined with other data on, for example, genetic data or other proxies for diversity, like ecogeographic land characterization, where you find then also proxies for high diversity that can be, let's say, very easily combined with threat vulnerability mapping.
Thank you very much. Maybe Chris, if I can just a follow-up question on that one. The methodology you use to estimate the threats and to map them, is that something you developed, or is that something that is widely recognized? Because when we talk about threats, we're always able to say what the drivers are, but I've never seen maps before. So is it something you developed? It's something that you found somewhere else that has been, adopted by the global scientific community, or what's, just to know how we can apply it. I mean, if you develop it, we can apply it, but it's just trying to understand like what's the level of confidence, let's say, that we have in this, in a way.
I mean, so we are still working on it. So we're trying to implement it, as we said at the beginning. I think it's now in a very interesting stage, or in a very stable, where the methodology has already underwent a couple of tests, and we started in 2014 to develop it. And it's definitely something that was not out there. So we're facing the same difficulties, basically. There was always, let's say, we knew that lots of threats were very important, but we couldn't find any spatially explicit way of measuring them. So this is something we developed, and I think what we showed in the presentation, also this sensitivity analysis now, is a way of assessing where are the factors that are most strongly affecting the results. And as Tobias showed in the presentation, in the creation of the threat exposure layers, and we found a solution to address that in working with best and worst case, or best reference and worst case scenarios. And so we have for each of these threat vulnerabilities 3 different maps that can assess, or where we are quite confident that we can assess the possible range of vulnerability situations. So we simplified it a bit in the presentation, but the methodology is available with the publication, and we're trying to implement or make it available to the conservation community as as broad and as in different regions as we can, because as we said, it can be implemented for different species. We show what type of information is necessary to have in order to come up with similar results or to run this analysis. And so this is why we are here as well, here in this project, and we try to implement it also together with some of you in certain areas.
No, thank you very much. And I really think that now that we have the opportunity to start some Rome process within the TRI, but not only the TRI. I mean, I'm particularly following Pakistan, and we're doing Rome now in Pakistan, and some other project that will have Rome starting. I think it will be really particularly interesting to insert this data.
Okay. Great. I think we should move, in the interest of time, we should move on to the next part of this session, which is a presentation from John Gongi from Kenyan Forest Service. So I'm gonna start John's presentation now.
Hello everyone, welcome to this presentation on integrating forest genetic resources for resilient restoration. My name is John Koge from Kenya, working with Kenya Forest Research Institute, KEFRI. The mandate of KEFRI is to conduct research in forestry and the right natural resources. KEFRI also disseminate research findings to stakeholders. We also undertake capacity building to stakeholders and establish partnership and collaborate with other research organizations and institutions of higher learning in joint research and training. KEFRI is also the leading executing partner for GF6 project, the TRI project in Kenya, the project known as restoration of arid and semi-arid lands through bioenterprise development and other initiatives. In my brief overview of KEFRI is we're involved in raising native seedlings in nurseries for restoration activities. We also develop technologies for restoration of degraded forests, woodlands, and wetlands. This can be either through passive or active restoration. We also undertake capacity building of our community and other stakeholders on restoration activities such as propagation methods and species site matching. We are also involved in developing dissemination materials to enhance restoration of degraded areas. These include development of brochures, pamphlets, and teaching aids. When it comes to deciding which tree to be involved in the restoration, there are quite a number of factors, and the most important is the site condition. We also address the issue of availability of tree germplasm, such as vegetative materials or seedlings, since in Kenya, we raise seedlings based on demand. The other aspect which we also address is the issue of cultural beliefs among the local people. Kenya is diverse with quite a number of different communities, and when we are introducing tree species within different regions, we have to address the issue of cultural beliefs so that the tree is not against their actual beliefs. So another aspect is consideration of the benefits which should be accrued from the trees to be introduced in the restoration. This is basically on the consumptive and non-consumptive benefits. When it comes to deciding which seed sources, we have quite a number of factors, and the most important is the seed source if you have desired genetic characteristics, the issues of health and adaptability, the issues of good growth performance, the size of the source for getting the seed sources will be big enough, and also we also look issues of ecological conditions, proximity to processing unit, and also the seed starts, since we have seed starts, but they are only for major tree species in Kenya. In our future plans, we would like to promote resilience by maximizing species and genetic diversity from seed sources. We have quite a number of guidelines in Kenya which guide the tree seed collections, but the main ones are two. We have the tree seed handbook for Kenya. This one is mainly for the technical people, for the technical staff of KEFRI and other institutions. And also we have the tree seed collection and handling guideline. This is mainly for the extension officers and farmers. This is a simplified version. We have quite a number of issues which I like today. There are 3 in number, and the main one is good to focus on to evaluate the impact of different restoration methods on genetic diversity. It is also important to package propagation of native species to promote their use in restoration. And there's also a need to integrate restoration of forest with the surrounding landscape.
Sorry, do we have a technical hitch there? Something went wrong. Can you hear me?
Yes, we can't see the screen anymore. We've lost the presentation. We can see you.
How long ago did it go?
1 minute.
It was just the slide.
Right. Okay. 1 second. I
Yeah,
don't quite know what happened there. Let me just.
This is basically on the consumptive and number of factors, and the most important is the seed source will have desired genetic characteristics, the issues of health and adaptability, the issues of good growth performance, the size of the source for getting the seed sources will be big enough, and also we also look issues of ecological conditions, proximity to processing unit, and also the seed starts, since we have seed starts, but they are only for major species in Kenya. In our future plans, we would like to promote resilience by maximizing species and genetic diversity from seed sources. We have quite a number of guidelines in Kenya which guide the tree seed collections, but the main ones are 2. We have the 3 seed handbook for Kenya. This one is meant for the technical people, for the technical staff of KEFRI and other institutions. And also we have the 3 seed collection and handling guideline. This is mainly for the extension officers and farmers. This is a simplified version. We have quite a number of issues which I like today. There are 3 in number, and the main one is good to focus on to evaluate the impact of different restoration methods on genetic diversity. It is also important to package propagation of native species to promote their use in restoration. And there's also a need to integrate restoration of forest with the surrounding landscapes. This is aimed at enhancing genetic diversity. So thank you very much. That's the end of my presentation. Hello, everyone. Welcome.
Okay, I hope everyone was able to get all of the presentation. Then I apologize. I'm not sure quite why the streaming dropped there. I think we'll move, as there's no very pressing questions for that presentation. The purpose is not to have lots of questions about these presentations. These are supposed to be primers for the breakout room discussion. So what I'd like you to keep in mind are those 3 questions and the way they were presented there, and how do you decide which tree species to use, how do you decide which seed sources, and if you have other issues that you would really like to raise in the context of seed sourcing and tree species selection. So I want to now hand over to Ray for his short intervention as well. I'm going to allow him to share his screen.
Okay. Okay. Can you see my presentation?
Yeah, perfect.
Okay, thanks. So what you can see on screen is that so I'm from the Forest Management Bureau of the Philippines. Basically, we are the main bureau that handles forest management, restoration, rehabilitation of all forest lands in the country. And so our main reforestation and rehabilitation program has been running since 2011, and it has a period of until 2022. And as you can see, we have 5 types of plantations that we develop under this program. Basically, the National Greening Program is a program of the government in order to rehabilitate and restore denuded and degraded forest lands in the country. And for production forest plantations, we have around 803,000 hectares already developed and rehabilitated. And then for the seedlings there, it's about, we have 1.7 billion seedlings already planted. But then again, those numbers will differ when it comes to counting the survival rate of these seedlings within the areas that they are planted in. So in deciding the tree species that we plant within the areas, within the forest types that you saw earlier, basically if the plantation will be developed for production purposes, it means that there would be communities there that would have to depend or would have to utilize the forest products within the area. Then exotic and fast-growing species will be used and will be preferred also, especially if the area is so degraded and so denuded that we need to prepare it first, and we need to prepare the soil first before indigenous species will be introduced in the area. Why? Because in tropical rainforests, indigenous tree species takes longer for them to survive and to grow within the given area, whereas exotic tree species have a faster growth rate in the Philippines. Actually, that's what we experience. But for protected areas and national parks, if ever we want to rehabilitate these areas, we use mainly indigenous species because we want to maintain and preserve the integrity of the area, and that's basically why we declared it as a protected area as a national park, because we want to preserve something out of those areas identified. And so how do we decide which seed sources? We have a government policy on how to determine seed production areas and also seedling production areas and how to collect them. So we have these number of indicators and criteria that you see here on your screen: height, diameter, breast height. These are the things that we consider in choosing mother trees or plus trees. So these are the seed sources. And then after collecting seeds from those seed sources, we still have another layer of seed viability tests conducted by a separate bureau, the Research Bureau, to determine whether the seeds are viable and whether they will actually grow within the given area where they're supposed to be planted. Some improvements for our seed sourcing in the Philippines could be like, we are basing our site species matching only on external and patent considerations. For example, the climatic type of the area, the soil type of the area, the needs of the communities within the area, and also the amount or the number of seeds available. We haven't gone deeply as to the genetic information and the not so much about the biodiversity consideration also in determining the seed sources and also the species to be considered for planting within a given area. And that's what we would like to improve on, and that's also why we're participating in these types of learning series. So that's it, and I hope you understood my presentation. Thank you.
Great, Ray. Yeah, that was really clear, very helpful and useful for formulating the next part of the discussion, which is going to be the breakout rooms. So for everyone's understanding, what I've done now is I've created in the background a series of breakout rooms, of which there will be one of our expert panel in each of those rooms. I'm going to assign everyone to a breakout room, and I just want to remind you of those 3 questions that we had. How do you decide about the tree species that you select? How do you decide about the seed sources for restoration? And those other issues. I think Ray's presentation really highlighted those very well in the current policies and strategies they have for seed collection. And perhaps to discuss those in your small group so we can bring those back to the plenary afterwards. So before I distribute everyone to the breakout groups, is there any points of clarification or questions anyone would like to raise? No, seems everyone is happy. So the breakout groups, we're going to run, just looking at the agenda now, we're running quite a bit behind. So I would propose it's now 12:30, so we're 10 minutes behind. We're going to have, let's have 20, so we can still go till 1 o'clock. So we've got half an hour in the breakout groups for discussion. Maybe we'll come back a bit earlier. Maybe you'll get an alert from me probably about 25 minutes to start wrapping up the discussions. And in each session, we're gonna the panel expert will report back afterwards, or will assign someone else to take notes and to help with this. And so the idea is that we really consolidate people's questions and comments and interactions during these smaller groups to then report back. So we'll let you sort of organically organize yourselves with the leadership of the panel expert in each of the rooms. So I hope that's clear to everyone. If anyone doesn't have has any concerns, please raise them now before I send you to your discussion rooms.
Chris, just maybe you could say again, you said it would be good if it's around 3 topics, right? And one was
so
how to decide about the species.
How do you decide about the seed sources, and then the other specific issues related to that are of concern, as Ray illustrated. So both Ray and John's presentations really presented those questions from their own perspective, and the idea is to discuss these further in the smaller groups. Okay.
Yes. Okay.
Okay. So I'm going to open all of the rooms now. And you should be automatically assigned. And Benjamin and Christoph, or Katerina, I haven't assigned you to a rooms, or Carolina either. So let me know if you want me to.
Yes, how it works? Sorry, I missed.
That's okay. Do you want me to? I haven't assigned you to a room at the moment. Would you like me to assign you to one of the breakout rooms?
Yeah.
Chrissy, if you can assign me to the one from Kenya, with Meshach, and I can follow them.
Okay, let me just check which one Meshach's in. It's okay. Yeah.
Put me in the room for. There is a room for each country.
No, I've split them into the different panels. I haven't done it by country. I've done it rather randomly, but with different people. So I can, if it's the specific people you'd like to be with, I can assign you to them. I'm trying to keep the numbers even. There's only 4 rooms, so. Carolina, you want me to assign you to a room?
No, Chris, thank you, because I have some other things to do, so I can take this time to keep working on the other things.
Okay, sure.
Thanks.
And Joyce, I don't think I've assigned you to a room, but you don't seem to be. Oh, yeah, I have assigned you to a room, but you haven't joined yet.
Sorry, I was directed to a room and then it came back, so I don't know what happened.
Okay. So how do you mean it came back? So I move you to another one. Let me see.
With Caterina Marchetta, the same room.
Katarina, I think, is dropped off the call.
Okay, so I see with her. I just text her and now I see. Okay.
Okay.
Thank you.
Actually, we are trying to get best practices for the tropical and subtropical forests and maybe the shrublands and woodlands in around at the global level, because the UNDK is working at global level. And I agree with Blaise that I found the same limitations, especially talking about tropical forests, that we don't know the traits of
Just noticing there are several people here who haven't joined the breakout groups. Did you have problems accessing them? Barry and Mutunga and Joyce?
Eliminates grazing potential, then the opposed to it. Then we have really to do a lot of negotiation beforehand to select the area and to select also the trees that will be accepted for the criteria that I already said: economical, social, ecological, and sometimes for recreation objective. And thanks for.
Okay, thank you very much. And let's have next Mr. Najib Magri. Please unmute yourself and go ahead. Okay, you will need to unmute yourself. I'm not sure if I can do it from here.
Yeah, of course.
Okay.
I'm Najib.
Okay, thank you.
I'm Najib Magri. I'm from the Forest Research Center in Morocco. Mr. Hajib actually is our director. So in addition to what Mr. Hajib said, what is the best way for the selection of species in the context of climate change, and also with dealing with some challenges due to economic benefits for local populations? Thank you.
Okay, thank you very much. Let's have next Mr. Ryan. Okay, please unmute yourself and share with us your views.
Yes, I'm Ryan Vita. I'm working with FAO Philippines Country Office. I'm the National Biodiversity, Environment, and Natural Resource Specialist. So basically, my experience in forest restoration work is similar to what Ray has discussed earlier. Mainly, the choice of species in the Philippines is determined under two considerations. One is for production, wherein the species is identified based on its marketability.
More in detail about really the methodology, how you choose the right species for your specific restoration site. No, that might be in a drier area or have different soil conditions.
About methodologies, but about methodology, but to identify these species, first of all, we make interview with government stratas and communities and the local community. We make interview and we identify and regarding this interview with government structures and the community and the local community, we identify more than 25 species. This is the first level of our studies, of our rapid studies, study to identify the species for restorations. But we must do another studies with our Institute of Research for Agronomy and another institutes to identify 3 species for restorations according to the recommendations of according to the recommendations of those presentations of webinar today. But Kenya presentations may be good for us. We must may be good for us. Kenya presentations. Yes.
Hans, if I can compliment, because I know also a bit the context of the project in DRC. I think like Rosca was saying, they've got 2 national institutions. Sorry, I had some background noise. So they've got 2 national institutions like that have got the capacity to have large-scale nurseries, but the government as such has not really a list of species as such for restoration. It will be on demand driven from projects from other institutions and and organizations. And with our project now, because we have gone in selection of sites for restoration, and like Oscar was saying, they did some surveying of communities and local institutions to identify the species. But a good thing to raise is, like also with the other presentation, is how you identify the seed source, but also do you include the capacity to actually
production, non-timber, and non-timber. We have also for production purposes. And inside those production areas, we have high-value crops like coffee, cacao, rubber, and for timber production, we have timber species, and for protection areas, we have what you call the indigenous species, native species. So that's what we did. We commoditized the things. It helped with the economy and also with the biodiversity, and also like a provision for food security of the community. So yeah, that's what we did. Prioritize seedlings based on, prioritize species based on the needs of the community, and also for the identified areas for protection. That's where we plant indigenous species.
Okay, thank you. Well, it's already 12:48 here, well, in Europe at least.
Sorry, I'm Dr. Bari.
Yes, Barry.
Sorry, I had some connection problem, so thank you. I just want one question, because these exotic are generally very fast growing and give good return, and sometimes small farmer cannot wait that long. So what could be the alternative for that?
Sorry, is that a question to me or to Yinia?
To Yinia.
Sorry, it's Jinya. Can you repeat your question again, Barry?
Generally, the indigenous species are a little bit slow growing, while the exotics are more fast growing. And if you go to a small farmer, they want quick return, so they will generally tempted to go for the exotics.
Eucalyptus, pines, cypress, and eucalyptus and pines. But when you come to the native tree species, you find them in our nurseries, they are very few. So initial promotion of our native, that is one of the issues which need to be addressed. The issue of policy, so that there is a lot of seedlings within our nurseries. Then what we normally do in Kenya is we have developed some tree seed sources maps, whereby we have mapped different areas whereby we can correct our local tree seeds, since Kefri is the main supplier of tree seeds in Kenya. We supply all the indigenous and also the commercial tree species seeds in all institutions in Kenya. But still, the demand is quite high. It cannot be the demand, because the sources which are mapped for the collection of native tree seeds is not adequate, and we are still progressing well with the mapping of those areas.
So when you say, John, when you say the mapping is not adequate, is that in terms of the number of species you are mapping, or is it in terms of the accuracy or the detail of the maps that you have for individual species?
Yeah, the number of tree species is not adequate, because we have not done detailed mapping. We are just going with the collection of tree seeds of the major indigenous tree species, not all.
So how many species would that be?
Yeah, currently the number of tree species you are collecting for the indigenous are around 30 to 40 tree species, which are quite low comparing that Kenya. We have quite a number of native tree species.
Mm-hmm.
Thank you.
Does anybody else want to add anything at the moment? So at the moment, what I see we've got from just quickly going around everybody, we've got this lack of knowledge about native species in terms of growth rates, general silviculture, site requirements, those sorts of things. We've got the issue to do with possibly not enough information about knowing where species are, indigenous species, so the mapping of them, the distribution, and then also a big problem with survival, which is related to mapping of the native species to the site. Is there anything else we want to add to that? Or anybody disagree with how I've summarized the discussion so far?
David, can I just add something? I think in a lot of cases, maybe there is some information, but it's not readily accessible for those people that are working on restoration projects. And maybe because it's with institutions like herbariums, you know, national research institutions that are linked more to the conservation world, and that have less of a practical or economic focus. And so there may be some information on species, but maybe it's not packaged in the right way for someone who wants to do a restoration project with some kind of economic outlook in terms of, you know, breaking even, and so it's not the right type of information in terms of how you might be able to derive economic benefits from these species.
Personally, I think that's a great point, and it relates to experience I had in Central America. So quite a few years ago now, I was working with Cartier based in Costa Rica, but throughout the Central American region. And we were aware that of this situation, that farmers are interested in a lot of native species, and the information was not available. The extension workers, people working with farmers, didn't have the information. But there is actually a lot of information in libraries, in publications, and it's just not available in the right language, either the actual language, English or French or Spanish or whatever.
The implementation of programs. In our field, we have to deal with some problems with the population, who in some cases have some fraud activities. So our agent, the forest agents, do their job very well, but the interior agents let go sometimes. So I'm just telling about some links in coordination between minister in the field, in the forest field, which can be a very, very treat for all the activities that we have to done in the field. So thank you.
Thank you. Next one, Ryan.
It's like, you know, even if it's come to choosing the different species, like in the northern part of the country, the forestry department, they have been promoting in the past only 3 like eucalypts. And I can tell you there are places now that the farmers, they are no longer accepting to have those exotic species in their land. So even if those eucalypts are planted, you know, in a state-owned, state-owned land, sometime at night, you know, the villagers, they will go there really to cut down those trees because they believe those eucalypts are completely taking, completely dry, you know, taking all of the water out. So they prefer local species from this area that are really adapted. So this is really some shift you see in the mind of people. But when it comes to really to the seed sourcing, I think there's still a lot of work to do there, really how to create, you know, the kind of value chain to improve, you know, and if people really can earn money from this activity, I think they are very open because sometimes you talk to the farmer, they know sometimes where you can find some of those, mother trees to collect it from those tree species that are local. But, you know, and those are sometimes information that the forestry department, they don't have because they prefer to focus only on those, you know, high value timber species. So there's probably a way also to give incentive to the community really to be involved in this area, and it can create some kind of stream of activity, or how people can earn money from those activities. And those are probably way also to improve the use of local spaces. And I think we may probably talk about it during the next webinar also. I think it will be one of the focus. But it's very good really to have. And I want to mention also for Asia, is something I've seen like in Indonesia at the Research Institute in Forda, when they have decided to select like 20 native fast-growing fruit species, and they're setting up experiments all over the country really to see how those species are really behaving. And just by doing this work, they now identify a set of species, local species, which are fast-growing, only to produce timber to replace species like teak that are really exotic, alternative to people. So maybe those are also area of research that most of the country we should also be, investing and working with the community, because they have a lot of information that can be very useful. So those are really some perspective I can share for now. Okay.
Thanks, Marius. That was Indonesia, the last country you said, or?
Sorry.
Where was the last one you said with the field trial? That was Indonesia.
In Indonesia, the
Okay.
Forest Research Institute for that. So yeah.
Okay.
Mhm.
Right. Then we're close to almost 25 minutes have passed. But I'm sure Chris will call us back when necessary.
Tobias, have you seen also Elias put some very interesting comment in the chat? So I
Yes,
hope you capture it. Okay.
I saw it too.
Okay.
Yeah. So what Elias said for the others also, so that they consider consider their productive capacity of the species, their ecological role also, and then also if they can be used in agro-silvopastoral systems. But they don't use, they don't focus so much on wood production in Lebanon.
I see you've come back already, David. Does that mean your group wrapped up? You're muted. Sorry, I was on you.
Yeah, we have. I thought you were telling us to wrap up. So
yeah, well, we've got one more minute, but I'm gonna collect the rooms now.
I think we'd gone as far as we could overall in terms of the time available.
Sure. Okay. Great.
Did you listen into various groups?
I did. Yeah, I did. I jumped about between them. So, right.
So I think if we'd, to go a stage further, we would have needed another probably 15-20 minutes. So we'd done the initial look at things.
Yeah, the idea is that we can follow this up in the next session. So, right.
Yeah.
Okay, so everyone should come back in 1 minute. Did it work okay though in terms of the platform and everything?
Yes, no, I think so. I mean, everybody, pretty much most people contributed, and yeah, we found the room okay. So that I think is much better than the previous one where I felt very dissociated from everybody.
Yeah, exactly. No, I think it was. Yeah, I think it was a big improvement. Yeah.
I think it's going to be 4 degrees tonight. So.
Ooh, winter's on its way.
Yeah. And we haven't had any cases here for 3.5 weeks now.
Well, in Australia at all, or in Canberra?
No, in Canberra.
That's good. Okay, so I think everyone should have returned back from your breakout rooms now. I hope the platform worked well for everyone and that you could all interact. What I would suggest we do now, as we discussed before, is that I will ask each of the people who were identified, which I'm assuming are the expert panelists from each group, to report back a bit on the discussion and from each of their groups, and maybe you could frame it around those three questions. First about the species selection, then about the seed sourcing in relation to quality and genetic diversity, and then finally about any other issues. So maybe, David, can I ask you to go first? I have to unmute you, or you unmute, yeah.
Yeah. We had a varied group. Some people from FAO, John from Kenya, and a couple of people from the Philippines. So different perspectives or experiences. I think in terms of which species to use, that question, some issues or commonalities came out in the sense there was talk about a lack of knowledge about native species, lack of information about growth rates, about their silviculture, site requirements, just general lack of information that would help in terms of planting these native species. And there was a comment made that probably there is information out there in publications of different types. At the moment, it's just not available to the restoration community. Then there was a comment also about site matching with respect to that limitation or lack of information about matching sites with species suitability and problem of lack of survival, poor survival of species planted in restoration sites. So that was mentioned. Then perhaps in terms of thinking about which seed sources to use, there was mention about a problem of a lack of good seed source maps. So really knowing the distribution of the species and not having enough, both maps about enough native species in terms of distribution, but also the maps not being detailed or refined enough, shall we say, in terms of allowing information about the species distribution. So I think those were the main facts that came out overall. I don't know if anybody else from the group wants to add anything, but I think those were the main consistent things that were mentioned.
Great. Yeah. Does anybody else from that breakout room want to add anything? Anybody like to respond to any of the comments before? Or I think what we'll do is we'll keep to the breakout room summaries first, and then we'll have a more broad discussion. So, Rina, can I ask you to go next?
Yeah, sure. Okay, so our group had representatives from the Philippines, Lebanon, Morocco, and then UNEP and FAO. So thanks for everyone who was in that group. So in terms of selecting the species, of course, the main considerations were economic, social, and ecological, but also the importance of cultural considerations in species selection was highlighted, and how that sometimes kind of overrides what is suitable for a certain area. So there might be constraints, for example, because of climate or fire resistance, but if local people don't agree on certain species that would be better suited, then it's difficult to do anything. So these kind of practical constraints, and overall also availability of species was something that was guiding species selection in some countries, and then sometimes there was no specific plan on what species to use where, but it's indeed driven by plans for well, what objectives there are for restoration, or what products or services are needed and what is then available. Something that was highlighted was also in terms of restoration, it's guided by what is practical. So what are the species that are available in that area, and so those are then used because it's expected that they are well suited for this area. In different countries, exotic species were used, but it was highlighted that these are difficult decisions. So there needs to be a lot of local consultation. There needs to be a consideration of invasiveness of the species. So somebody mentioned that often people tend to think that invasiveness is not an issue if we manage these plantations properly, but that is actually not always true. In terms of the selection of the seed sources, so in one of the countries, they are now trying to develop maps for where to collect seed for different species. This has not existed before, but and so, yeah, so there have not been very well-defined maps. But now there is a high interest for developing a model that shows what species can be collected from what areas. Problems for seed availability for native species and endemic species were highlighted, partly because these species can't be stored, so often the seed is recalcitrant and it won't keep for long. And then there is pressure in terms of illegal logging or unsustainable use for these species that has caused the native or natural seed sources to diminish. So sometimes there are very few mother trees left. And sometimes because of the issues of seed viability or longevity, wildlings have to be used, and those have sometimes had very low survival rates. But there were some good practices identified on how to improve that viability. We ran out of time when we started to talk about the current policies and strategies for seed selection. But that's a summary. If anyone from the group would like to add anything, please.
No other points from Rena's breakout room? No? Everyone happy with that summary? Great, that's a great summary, Rena, thanks. Who's next? Hannes? Was it Barbara?
Barbara would exactly took notes and would report back to the group.
Fantastic, Barbara. Maybe Barbara, just introduce yourself, because I didn't mention you in the introduction. It would be great if you introduced yourself to everyone.
Yeah, so my name is Barbara Vincetti. I'm part of Chris' team. I'm a forest ecologist based in Rome. So I'm helping out with this summary of our session. So we had quite a long report from Oscar from DRC and from Elia from Kenya. We didn't systematically cover all the points, but we have some ideas about critical issues that are emerging and which we could also provide assistance. So for the sites for the initiative in Congo, basically the species list is produced based on requests from individual projects, individual initiatives. And there are two national research institutions which are in charge of providing support and also can establish large-scale nurseries. But there's a problem of capacity to handle such a large diversity of species. So for the particular sites and initiatives in which Oscar is involved, they have come up with an initial rapid list of species, which derives from discussion and consultation with the communities and other stakeholders from the government, but they still have to finalize and go through different rounds of approvals of this list, and also consulting these research institutions. But the main concern they have is about propagation protocols. So it's not really clear for how many species propagation protocols are already available. And they're also thinking about consulting neighboring countries like Kenya and Rwanda to check whether they have much more experience on the species of interest, and they have developed more advanced seed handling procedures and propagation protocols. So propagation protocols is a critical issue. We didn't go into discussing seed sourcing and other aspects, but they're still in an early process of identifying the species, and the list they generated is mainly coming from the needs of the local communities, and it has to go through also consultations with research institutes that can help also with additional knowledge on the species selected. For Kenya, Elia basically described different processes through which we see tree planting in the country. There's a lot of individual activities taking place within agroforestry systems. And within these systems, individually managed, there's not so much attention to the diversity of species because the objective is to maximize a particular goal. So there's not so much attention to diversity of species used. But within governmental-led initiatives, in which research institutions are also involved, like KFRI and the Kenyan Forestry Service, there's a lot of consideration about maintaining a sufficient diversity in the restored forests. So for the moment, there's a lot of attention to the needs of local communities in tree species selection. And there's also really quite an advanced understanding of the need to respect some transfer boundaries. So they have developed transfer guidelines for a number of regions. They don't have species-specific transfer guidelines, but they have quite an advanced understanding of how much you can move material within the country. So they're very much paying attention to that, and they need always governmental permission when they want to test material outside the region of origin. And they need to be much more conscious in future about climatic conditions, which are becoming very limiting for some species to properly get established. So they want to include much more climatic considerations in the future selection of species adaptiveness to the sites of interest for restoration. And they also think that there's a need also to promote more widely at the country level and with the communities, the need to restore degraded sites, to have the full engagement and full buying in of communities. So some more efforts in raising awareness and getting the communities on the same page as the government in terms of goals for restoration. Yeah, this is it.
Yeah, thank you very much, Barbara.
Yeah.
Great. That's great. Maris,
yeah, I think, yeah, maybe just to add, I mean, I think there was not enough time also to talk more in detail about this issue of climate change. That seems a very important one, but because this is something where we could relatively easily help out, and we couldn't go ahead with the discussion also with Benjamin on that. So what it would actually need to help out with that and to implement it on certain species. So maybe this can be done in a next discussion or so. It would be something, I mean, where we have definitely expertise, and it could be something where maybe Tobias, myself, you, Barbara, could be present. And because this is something now with occurrence data and with the methodology that we showed today on climate change vulnerability, that would fit extremely well and could help to reduce the risk of planting tree species that are not finding suitable habitat anymore because of climate change in certain restoration areas.
Yeah, great point, Hannes, and I'll come back to that at the end as well. I think it's a very important point. So Tobias and Marius, which of you from your group is?
I'll report on
okay.
Our group. So, well, we had participants from Lebanon, Philippines, Pakistan, Cameroon. So first, starting with the tree species. So which species to plant? Some things that were mentioned were, for example, well, first of all, it depends on the restoration objectives. But things that can be considered are, for example, the ecological role of species in the ecosystem. Then what was also very important for several participants is the provision of timber and non-timber products for local communities. Also the use in agroforestry systems, yeah, and then some other things also to consider is for example their growth rates, how easy are they to germinate, which trees are there in the reference ecosystem. Tree suitability maps were also mentioned, so that's nice. And then in areas from Lebanon also mentioned that there is a lack of a robust way to like I already said before, to match the tree species with the site conditions and the objectives. So yeah, there's a bit the lack of a system or a tool to do that. Then going further on the tree species, there was also some discussion about indigenous versus exotic tree species. So there was some agreement that indigenous species are better for biodiversity conservation, but then in different countries there were some difficulties to convince restoration practitioners and local communities to actually use them also. So for example, in the Philippines, there were like practical constraints, like difficult to germinate, difficult to survive. And then also that local communities prefer exotics for timber. Also in Pakistan, there was a similar experience. That they have a big tree planting program, and where they're trying to promote 50 local tree species. But then in the end, locals keep asking, give us eucalyptus or some other exotics. So some difficulties there too. And then on the other side, Marius in Cameroon, he commented that in the north of Cameroon, it was like that in the past as well, that people preferred exotics, but now that their attitude has really shifted to preferring native species, and they don't want eucalyptus at all anymore because of its high water consumption. And then a final comment mentioned on that is also from Marius, is that in Indonesia, they're now doing a field trial with 20 fast-growing native species. So basically to identify those native species who can really compete with these exotics also in terms of growth rate. And yeah, that experiments like that in other countries would be interesting to make indigenous species more interesting, not only from a biodiversity perspective, but also just because they also can, I mean, there are also indigenous species that can grow fast, of course. Then, well, we spent quite some time on that already. For the seed sources, several times it was mentioned, yeah, that it's best to collect seeds from plus trees, from protected forest areas, consider diversity and these things. But for example, in Pakistan, Bari commented that in the past, people used to do these things. So look for the plus trees and consider diversity and these guidelines. But nowadays, with their tree planting program, the target is so high. They have to plant so many trees that people simply don't have the time anymore to do all these things, and so they end up simply getting the seeds where they can get them, and then not considering these guidelines anymore. In the Philippines, there was also the problem a bit with capacity of, so that they're doing quite some community-based restoration, but there's then sometimes a capacity problem of the farmers, that they don't have the capacity to collect the seeds in the right way. What was also mentioned in the Philippines was that there's a big lack of knowledge how to best store the seeds of the indigenous species, because they use viability quickly often and those kind of things. And then in Cameroon, it was commented that there's still a long way to go for concerning seed sources. So there are some seed sources from high value timber species, but for many other tree species, there isn't there aren't any official seed sources at all, and it would be important to also develop seed sources of these species, and importantly also to involve local communities in seed collection and to link these local communities in that way, to provide seeds for restoration projects, also as a way to provide income for these communities. And that's about it for our group.
Great, thanks, Tobias. Marius, you want to add to that?
Yeah, I want to add something, and I think it's also related to what Barbara said for DRC, because for this project, we are also supporting like the team in Central African Republic, and it's the same thing, you know, the lack of a basic knowledge about the species and how to propagate and reproduce them. So it's like, I mean, Eman is not online, he went there, and we end up now like, but we really keep it to a very small number of species. So they have like 30 native species, and we are now preparing to them like a technical guideline, you know, we've looking through literature, even going through some nursery in Cameroon. We ask them to do the same thing in the country, really, to collect and for the knowledge about those species, and we return it to the technicians so they can really use them to plant in the field, because there's really a lack of knowledge about those native species. And of course, we have so many tree species, we can't deal with all of them. So we really need to also be realistic and work with a small set of species sometimes, and maybe try to go to detail and provide those knowledge to the people who are doing the restoration in the field. So that's what I want to add.
Great, thanks a lot, Marius. Is anyone else like to add any points from there? Or any other interjections related to any of the discussions or the points that have been raised today in the breakout rooms that I'd like to highlight? We've got a few more minutes. No, even with quite a long pause, no one wants to add anything. Oh, David wants to come in again, yeah.
Okay, I will just, I mentioned it to our group, but just an experience we had in Central America, where we found some years ago a similar problem about lack of information, availability of information of native species. And we felt there was a lot of information, but it wasn't just not available, it was hidden away in journals, in scientific publications, all sorts of things. And so we produced a book for extension workers with this information gathered together from lots of hundreds of different publications about these different requirements of native species. So we covered 199 native species, and the book was directed specifically at extension workers with a number of different search tools that would allow them to look for the right species for the particular climate conditions they were in, and the uses, particular interests of the farmers in terms of uses. So I can share that. I was sharing that with the group I was in, but I'm happy to share it with the whole group and put it up as a resource, because I think it seems to strike a chord with what people are saying about information availability.
Great. Okay. Thanks, David. That's useful interaction. Yeah. And Ray, you want to throw your hand up?
Yeah, thank you, Chris. I'd like to take off from what Tobias mentioned earlier that
I also want
because
one comment, if you like.
Okay, Barry, we'll
Hello?
come to you afterwards. Yeah.
Mike?
We'll come to you afterwards, Barry. Ray's just talking.
Yeah, one.
Okay. Could you please wait, Barry, until Ray's finished? We'll come to you.
Okay, so I'd just like to take off from what Tobias said earlier about his group, saying that because of the large targets and the short amount of period of time for these reforestation projects, especially those government-led, we tend to just, scrap science, scrap genetics, scrap sites, species matching out the window just to meet the targets. Because what I presented earlier, especially for my case in the Philippines, the millions of seedlings planted, those were only planted, those were counted the time they were planted on the ground. But then if you add a column for seeds that actually grew into trees, then you'd have very glaring numbers there that we have to consider. And I think this group is in the position to convince governments and countries that in doing reforestation projects and doing rehabilitation projects, especially FLR, we should not be driven and boxed around targets and short periods of time. We should do it scientifically, we should do it economically, and we should do it socially. So that's what I want to raise to the group.
Okay. Great, thanks, Ray. That's a great intervention. Yeah. Okay, Barry, please, now you can talk. Go ahead, Barry. Nope, we can't hear you. Okay. Did you still want to add something, Barry? Okay, so Elijah's also put in the chat, the issue of natural regeneration of trees is a critical support diversity, but dominant species may diminish some species. Yeah.
I think one was this point that.
Yeah, please go on.
Okay, so the main problem is also the target. The other thing is that besides seed, in the bigger program, there are a lot of cutting used, and those quality of the cuttings, like in poplar, most of the things are generated from the cuttings. So we have to also take care that how the cuttings quality is ensured from which trees they are collected. This is also a big contribution to the plantation, and if they are not correct, then the future crop will not be correct. Thank you.
Okay, thanks, Barry, for that intervention. Saeed, yeah. No, you're still muted. You're still muted. Can you unmute?
Can you hear me now?
Yes, we can hear you now.
Another issue is very important for us. It's the seed certification or traceability. We are dealing a lot with private sector. They provide for us seeds, but sometimes these guys, they have stocks. They store seeds for 2 years, 3 years. And when we use them in the forestry program, we have the growth rates really very weak. And it's time to see how can really put policy or regulation on this issue, traceability and certification of seeds.
Okay, great. Thanks, that's a good point. So Benjamin, you have your hand on, and then I think it's going to be the last intervention because they're going to run out of time.
I don't want to be the last, but yes, just want to raise with the TRI program, we are working with IUCN to look at their methodology to analyze the certain species that can be helped with restoration efforts. They use STAR, species threat abandonment analysis, and they can influence the type of restoration options for a particular species of animal at this stage? Is that being considered in your mapping exercise to look at restoration option and species, site selection for seeds?
I'm not sure I followed the last bit of the question. Do you get the question, Tobias?
I'm not. I also missed the part.
Sorry, I can rephrase.
Yeah, I understand the STAR initiative is to really look at quantifying the biodiversity benefits of different restoration interventions, right? So you're asking whether the tree species component could be integrated using our approach.
Yes, because looking at the biodiversity and the animals using certain species, for their ecology.
Yeah, for sure. So actually, yes, I mean, because the trait-based analysis actually looks to different traits that could make species particularly valuable to different forms of biodiversity, whether it be insects or birds and fruit and flowers and pollination. So there certainly is a potential, but at the moment it's not implemented in that way, other than to enhance the species selection to meet biodiversity benefits. But there would be a potential to link it to something like the STAR classification. Okay, does that answer your question, Benjamin?
Yes.
Okay, great. Okay, so I think we've come to an end. We're already out of time. I didn't really have time to summarize, but I think we had fantastic summaries of the discussion by each of the different breakout rooms. There's a couple of points I thought worth highlighting. It was really interesting to see that given that the topic of this discussion and this session was about is local the best, and there was already a lot of discussion about exotics versus indigenous species, whether you look at actual local origins or not. And I think this is a really important topic, given that we're really trying to look at what creates resilient landscapes. And so while exotic species might be particularly valuable in the short term, they may not deliver many of the benefits that are desired through restoration in the long term, or they may be a really useful interim phase in certain restoration interventions. But that said, we still seem to lack a lot of awareness about what native tree species benefits can be delivered. We're recognizing that there's multiple objectives we want from restoration, but there seems to be a disconnect between accessibility and availability of what are the benefits of different native tree species, where we can get them, which is why I thought it was useful to have the whole species distribution and threat mapping analysis as an introduction to this discussion, because we really need to understand where tree species naturally occur so we can understand what are the best and most suitable sources of seed that we can use for future restoration activities. I think it's also really important to remind ourselves that this session is about looking at the genetic diversity, and as it's been really nicely illustrated through this discussion, there's been a failure to integrate those because the targets are often set so high that we can't afford to invest in implementing the science and the guidelines, which we know will be best practices. So whatever solutions we propose have to be really easily implementable and feasible within the local context. And I think the next session in this webinar series, which is really going to be looking about the decision support tools and the monitoring and evaluation tools that are currently available and which have been developed by the Alliance of Biodiversity and SEAT, really kind of address those questions in a specific way about how we can support the decision making to better inform using the existing available data from different species distribution, but also an understanding of the trait data. But for many native tree species, we're really going to need to continue to collect information about the traits of the species. And so working with partners is going to be really important to be able to quickly build those decision support tools for other regions and countries. The climate data point of view, I think, is really hugely important, and we've only just started to touch upon, as Hannes suggested, if we don't consider suitability and a genetic adaptive potential, then all of these targets being met may be met in terms of number of trees in the ground, but they're not going to be trees that are adapted to future climate change and therefore not going to survive. And as you say, Ray, the numbers are going to be actually benefiting society in the future are going to be much lower than the number of trees that are being put into the ground now. So I think the next session that we have is really going to deal with these issues more concretely, and I really think that this platform worked very well in terms of allowing us to start this discussion among the different participants in the breakout rooms. And I recognize that there was probably not enough time to follow up those discussions, but in the next webinar, we can perhaps allow more time to build those discussions and come to some more clear understanding of the available solutions and what needs to be done in the future to ensure that the best guidelines that are available and the best tools that are available are being implemented in an effective way to ensure future landscapes are resilient to climate change and deliver multiple benefits to society. So I think with that, unless there are any others, I would like to ask everyone to put their cameras on so we can have one final thank you to all of the participants of this session. I think it's been a very interactive and useful discussion. There's been a lot of topics covered, and I think it lays the foundation for a really fruitful discussion in the next webinar, which will really deal with these issues of supporting a suitably adapted and genetically diverse material for restoration in the future. And I'd just like to add thanks to everyone who's responded to the poll that I launched a few moments ago. And so it's unanimous that everyone found this webinar useful, which is a great result. And actually, it's very split between useful and very useful. So it's nice to see that a lot of people found this very useful and everyone found it useful. So thank you all for your participation. And if I will hand over to Christophe or Benjamin in case they want to have any last words. No?
Benjamin.
You summarized well. We just need to confirm the date for the next webinar together.
Yeah. Okay. Yeah. So it will be in the next, I think, 4 to 6 weeks. I think. Yeah. Yeah.
Okay. Bye bye.
Okay. Thanks everyone for your participation.
Thanks everyone. Bye bye.
Bye.
Thank you. Bye bye.
Goodbye. Goodbye.
Bye bye.
Bye bye. Bye.
Allô, Lambry, c'est comment? Oui, mais c'est comment? Non.